In this video, we will look at factoring trinomials. By the end of this lesson, you should be able to factor trinomials and binomials. Let's look at situation number 1. We're asked to find the zeros for the following quadratic function. So we're given this function and to find the zeros for it. So far, we have found our zeros by looking at our graph and seeing where the parabola, remember a parabola is the shape, crosses or touches the x-axis. Remember our zeros are the x-intercepts, the roots, the solutions. We're looking at where it's touching. We can't really tell that from looking at the equation. We would usually look at the graph. So if we take a look at the graph, it looks like this. I've graphed it on my calculator. Y equals 15x squared minus x minus 2 looks like this. So if I were to find the zeros of this graph, it says, notice that in this graph, the zeros are not whole numbers, which makes it difficult to identify what they are. So here we don't know. Here's -1 and here's 1. We're not 100% sure what those are. They are some sort of fractions, but we don't know what fractions they are. So we must factor this trinomial to determine what the zeros are. We need to find the factors of them. So if we look at that example, we are going to factor each polynomial in these examples. So we have our steps up here as to how to factor trinomials. So my first step is to make sure the quadratic is in standard form, ax squared plus bx plus c. Well, I see here I have ax squared plus bx plus c. I have this format right here, so that one's good. Check for a GCF to factor out. So I want to look at all 3 of my terms and see if there's something I can divide them by. Well, I look at 15. This is a -1 here and a -2. I can't divide those numbers by the same thing. And then I look at x squared x, and this one does not have an x, so no GCF. So I'm good there. My third step says write the trinomial with 4 terms. What that means is I have 3 terms right here. It's a trinomial. I have 3 terms. I want to write it with 4 terms. So what I want to do is make this term into 2 terms. I want to split that term up. Okay, and in order to do this, I need to follow a specific pattern. So you're going to go ahead and draw this little X on your paper. Okay, because what we're going to do is find 2 numbers. We need to multiply 15 times -2. You're going to multiply A times C. So in this one, we're going to multiply A times C, my A number and my C number. So my A number is 15 and my C number is -2. So I get -30. I'm going to put in the top of my X. My B number, so if we look here, ax squared plus bx, so it's in the middle, -1, is going to go down here. Okay, so I need to find 2 numbers that will multiply to give me -30 and add to give me -1. So what I want to do is look at the factors of -30. So I got 30 by doing 15 times -2. Other factors of 30, I'm going to get 5 times -6, 30 times -1, 10 times -3. Now what I want to do is combine those together and see if I get -1. 15 minus 2 will not give me -1. 5 minus 6 does give me the -1 that I am looking for. 30 minus 1 does not give me -1, and 10 minus 3 also does not give me -1. So there I have found my 2 numbers. These 2 numbers multiply to give me -30, and when I combine them, I get -1. So I put 5 and -6 over here in my X. So now when I set up I want to make this from 3 terms to 4 terms. So I have 15x squared. Now instead of -1x, I want to write, I'm going to write plus 5x minus 6x. I'm splitting this into two terms, minus 2. Now I have a four-termed expression like we had in our last video. I want to factor by grouping. I'm going to group my 2 together. I'm factoring by grouping. So now I look for the GCF here, which is 5x. I put my 5x on the outside. I'm left with 3x plus 1. And over here, my GCF is negative 2. So I put negative 2 on the outside. I have 3x, negative 2 divided by negative 2 plus 1. Finish it just like I did it in our last notes. So I'm going to divide both of these by 3x plus 1. So I have 3x plus 1 and 5x minus 2 are my two factors. So I have now factored this expression. It's a lot of steps. Let's take a look at another example together. Let's look at example 3. Factor each polynomial. Same thing. My first step is always to make sure the quadratic equation is in standard form. Check. Check for a GCF to factor out. So now I want to see if I can divide all three terms by something. Well, I look at the numbers 2, 14, and 20, and I can factor them all by a 2. So I have 2 times x squared plus 7x plus 10. That is what I'm left with there after I factor it out. So now I've factored out my GCF. Write the trinomial with 4 terms. This is where we need to make our x again. And we need to multiply a times c. But this time we're working with what's down here. So I have a 1 here, and I'm going to multiply 1 times 10. So I'm going to do a times c. I get 10. My b is 7. So I need two numbers that multiply to be 10 and add to be 7. So let's look at the factors of 10, positive 10. So I have 5 times 2. I have 10 times 1. Let's pause there. If we need to use negative numbers, we'll try that if we need to. So let's see, 5 plus 2, if I add that together, that gives me 7. There we go. 10 plus 1 does not give me 7, so that doesn't work. These two do, though. So I have 5 and 2. So I'm going to break up. My 2 stays with me here. I'm going to break up. I'm going to leave x squared alone, but I'm going to break up my 7x into my two terms, plus 5x plus 2x plus 10. Okay, so what I did, I broke up 7x into those two terms, went from 3 terms to 4 terms. And now I'm going to group just like I did before. My 2 stays with me. It just follows along. I'm going to divide these by x because that's the GCF. X plus 5 is what's left. And divide these by positive 2 because that's what's left here, plus 2, x plus 5. I'm going to close the parentheses. I'm going to close the parentheses for my 2 there. So now I notice here that I've got these x plus 5s in common. So I'm going to divide both of these by x plus 5. So my final factors, these will cancel, are going to be 2. Then we have x plus 5. And what was left, x and a 2, x plus 2. So those are my factors. The 2 was a factor because I was able to divide it out. These are my factors. Okay. Now we also want to look at binomials. If we notice in example 5, if you flip your paper over, we're looking at example 5, I want to factor the polynomial, but it only has 2 terms. So in this case, this is not a trinomial, this is a binomial. okay, because I have two terms. So I'm going to factor it the same way. Okay, make sure the quadratic is in standard form. It is in standard form, but if we notice, there's no b term. So I can rewrite this to say x squared plus 0x minus 9. That's what that means. There's 0 in there, okay? 0x means 0, okay? So I can write it in standard form. Check for GCF. I don't have a GCF. Write the trinomial in 4 terms. So that's where I'm going to use my x here. I want to do a times c, 1 times negative 9 is negative 9, and my b term is 0. So I need two numbers that multiply to be negative 9 and add to be 0. So let's look at the factors of negative 9. So I've got 3 times negative 3, 9 times negative 1. 3 minus 3 does equal 0. 9 minus 1 does not equal 0. So there are my two numbers, 3 and negative 3. So I'm going to take my expression here, same thing, I'm going to split up my two terms, plus 3x minus 3x minus 9. I split up 0x into those two terms. Now I need to group. I'm going to group my terms together. Divide by x plus 3. Divide by, you always want to divide by the number that's first. So since it's negative 3, I'm going to divide by negative 3. Okay, so now I'm going to divide both of these by x plus 3. Divide by x plus 3. They will cancel. So my two factors are x plus 3, and I'm left with x minus 3. And those two are my factors. Okay. So if we notice here, there's actually a special pattern with binomials that we want to take a look at really quick. So if you look below this example, we say we have this pattern called the difference of two squares. We have this pattern called difference of two squares. So if we have something that looks like our example before, if we notice in our example I have x squared and I have minus, I have subtraction, and I'm subtracting 9. So in that example, if you see with x squared, we had something squared minus, you always need subtraction. That's why it's called difference of two squares. And then we have b squared. And if we notice in our example, 9 is a perfect square. We have 3 and 3 that give me 9. So that's what we need to do this pattern. We need two perfect squares and subtraction in between. If that happens, then we can follow this pattern, a plus b times a minus b. So let's take a look at an example of a binomial that follows that pattern. So like we said here, I have in example 6, I have two terms, I have my binomial, and I have subtraction. So I can use this pattern. So what I want to do is identify a and b. So I look at my first term and I see y squared. The square root of y squared is equal to y. When I look at my b, I look at my second term and I say, what's the square root of 25? And the square root of 25 is 5. So I'm going to use those and follow my pattern. So I'm going to take a, which is y, plus my b, which is 5, multiply it by a, which is y, minus my b, which is 5. And those are your two factors. You can always factor the way we did in the beginning of this video, but this can be a shortcut if it follows this special pattern. This is a special pattern for factoring. We've reached the end of our video today. Please make sure you bring your notes with you to class, and we will continue to practice some of these examples together.